Okay, looking at the concentration of vinegar, and we're asked to find the volume of potassium hydroxide required to neutralize 25 mils of a particular type of vinegar. This vinegar, though, is given to us with a concentration in an unusual way. It's given as mass. In other words, concentration here is actually equal to, concentration is equal to 3 grams per 100 grams. And that's a bit of an unusual thing. Normally we're given mass per volume. This time we're given mass per mass. Okay, well, to actually calculate molar calculations, we need them in terms of mass per volume. So we're going to have to do something about that. I draw to your attention the density is mass divided by volume, and here we're given a density value of 1.01 grams per milliliter. This is actually 1.01 kilograms per litre, and it doesn't hurt to translate it into the units of volume that you'll be measuring in. Okay, so concentration, we're told, is 3 grams per 100 grams of solution. We're given in mass per mass, but we actually need to do our sums mass per volume. Okay? In other words, this is what a molar concentration is. It's the number of moles in the number of litres. Okay, so one thing that we can multiply by is mass divided by volume to convert mass into this. How does that work? If you consider mass divided by mass of solute times mass, so this mass and this mass actually cancel out, leaves us with a mass divided by a volume, and that is the correct dimensions for this particular problem. So we know that to convert a mass problem, if we multiply the mass by the density, then we will convert it to a mass volume problem. Okay? In other words, so if we multiply our 30 grams per kilogram by 1.01 kilograms per litre, we get our answer in the units of 30.3 grams per litre. And now we can do molar calculations with this. Grams per litre is easy enough for us. To convert it to moles, we need the molar mass, which for acetic acid is 60.05. So we've got 30.3 grams per litre divided by 60.05 grams, and this will give us a value of 0.5046 molar. Now, once we've got the molar concentration, we can use our formula. Number of moles equals concentration times volume. Okay, which is equal to 0.4056, this value here, times 0.025 litres. That is, okay, we'll put the litres in there. That litres comes from the 25 ml of vinegar that we added. So the number of moles in that 25 millilitres is 1.26 times 10 to the minus 2, and I'll just stick the units in there for it to make it nice and clean. Moles. Okay. Now, we're asked, what's the volume of potassium hydroxide required? Well, that's easy. Volume equals the number of moles divided by the concentration. We're told our concentration is half a mole per litre of potassium hydroxide. So we take the number of moles that we've calculated, divide it by the half litre concentration, and we get this value of 2.523 times 10 to the minus 2 litres, or if you prefer, 25.23 millilitres. And that's pretty much straightforward. That's how to answer that question. Just remember to convert a mass concentration, in other words a certain number of grams per mass, into a mass volume concentration, you multiply by the density, okay, which is given in grams per millilitres or kilograms per litre. And that is that.